everybody, it's Mrs. Mancuso. I'm going to do the last part of the August 2016 exam with you. So when you come to these part twos, sometimes there's a lot of reading here, and it's talking about some reaction. So I would just go right to the questions first. So explain why the Fe atoms in the bicycle react with the Cu plus 2. So if something reacts, it is because it is more active. So you'd write Fe is more active than Cu plus 2. So you can also look it up on table J, and on table J, Fe is much higher than Cu, which means it's more likely to oxidize. Sorry, my writing is terrible on this little screen, but you get the idea. All right, determine the number of moles of hydrogen gas produced when 0.001 mole of HCl reacts. So that's a little recipe problem, or stoichiometry. 0.001 HCl is what I'm given, times what I want is H2, what I have is HCl. So you always do given times want over have. And then you go up here. HCl has a 2 in front of it, so that means you put a 2 there. And H2 has a 1 in front of it, so you put a 1 there. 0.001 times 1 divided by 2 is 0.0005 moles of H2. All right, write a balanced half reaction for the reduction of the hydrogen ions to a hydrogen gas. So you go up here, here's my hydrogen gas, that's at 0. And here's my hydrogen, and it's at plus 1. So I have 2 H's at plus 1, plus I've got to add electrons before the arrow, and then it's becoming hydrogen gas. So if I go from a plus 1 to a 0, and I have 2 atoms, so it's a change of 1 times 2, that would require 2 electrons. So reduction is gaining, so that's why I showed them before the arrow. So there's my half reaction. Describe one change in the HCl aqueous that will increase the rate at which hydrogen bubbles are added. If I want to make it go faster, I would just increase the concentration of HCl. If you have more HCl, then you have more molecules to collide. So that's the best answer for changing it. You could also heat it up, but I think increasing the concentration would be the best because you have to choose something that is a change to the HCl. All right, so this one, what is it showing me? I've got 4 beakers, they've got water, they've got salt in them. Oh, and it's changing the boiling point. Oh, you know I love to go bloop. So here's normal boiling, here's normal freezing. You add something in and it goes bloop. This goes down, this goes up, so your boiling point increases and your freezing point decreases. All right, so identify the solute and the solvent in this reaction. So my solute is what's being dissolved. That's NaCl. And solvent is what you dissolve it in, so that's water. Show a numerical setup for calculating the percent by mass of NaCl in beaker 4. So go over here to beaker 4. You've got 100 grams of water and 35.04 of the salt. So part salt is 35.04. The whole is 135.04. So I always want part over whole and then times 100. So that's my correct numerical setup for what part salt is in this mixture. All right, next one. Explain in terms of ions why the ability to conduct an electrical current is greater for the solution in beaker 4 than for beaker 1. All right, sorry, I already ran this video once. I was having some trouble with it, so it looks like I didn't delete this. So the answer is beaker 4 is going to be better at conducting electricity than beaker 1 because it's got more ions. This has 8.76 ions, or grams, and this has 35.04 grams. So more ions means more charged particles, and those charged particles are what make it conduct electricity. All right, state the relationship between the concentration of ions and the boiling point for these solutions. So up here, I see that this one's boiling point went to 101.5. and this one went to 103, 104, 106. So the more solute that you add, the greater the boiling point. So the relationship is as the concentration of ions increases, the boiling point increases. And again, I would write out increases and I would write out boiling point, I would write out concentration, but since I'm just going over it with you, I'm not gonna. All right. Determine the change in oxidation number of zinc during this cell. So zinc starts at 0, it's all alone, so it's by itself here, and I know O is a -2, so Zn is a +2. So the change is 0 to +2. That's the change in oxidation state. All right, compare the number of moles of electrons lost to the number of moles of electrons gained. Oh, it's going to be equal. However many electrons you lose is how many you gain. That's how redox works. Using information in the passage, state one risk and one benefit. All right, I love these. Something from the passage is going to make it really easy. Mercury batteries were used because of their miniature size, even though it's toxic. So the risk is that it is toxic. Oops. And the benefit is that it can be very small. All right. A company produces a vinegar using thymol blue, titrated out. What's the color? Oh, here's another one I didn't get rid of. So I went to table M and I looked up what an acid is, and an acid in thymol blue would be yellow. Identify the negative ion used in this titration. So Na is a +1. I don't want that. So I want OH, and OH is hydroxide, and that's a -1. You could write out the word hydroxide ion, or you could just put OH -1. All right, the concentration of the base used in titration is expressed to what number of sig figs? So here's my base, molarity is my concentration, and it's 0.30. Notice how I didn't even say 0.30, that's because 0 is a placeholder. So 0.30. That 3 is significant, and you'd never go putting a 0 after a decimal, after a number, unless you actually measured it. So those are 2 sig figs. This one is not significant because that's just a placeholder. All right, determine the molarity of this using titration. Okay, so on the back, titration, MAVA equals MBVB. So now I just look up all those values. I want to find the molarity of the acid, so MA is my X. The volume of the acid that I use is 15 milliliters. The molarity of the base, we just talked about that, is 0.30. And the volume of the base is 43.1. All right, so now to solve, divide this side by 15, divide this side by 15. All right. And that is not a decimal point. I'm just multiplying by 15. Okay, so I've got 0.3 times 43.1 equals, divided by 15 equals, I get 0.86. So the molarity of the acid is equal to 0.86 molar. That would be my answer. Sorry, 0.86 molar. All right. Here I've got some reactions. I'm going to go down to the question. Identify the element that causes it to be classified as organic. If something's organic, it's got carbon. Identify the type of organic reaction in equation 1. So I got to scroll up here to equation 1. Equation 1 starts with glucose and it makes ethanol. So if it makes ethanol, it's making alcohol. That's fermentation. Fermentation. You always notice it as being different from combustion because it doesn't have oxygen going in, and it also doesn't make carbon dioxide and water. It makes alcohol and carbon dioxide. All right, explain why the hydrocarbon in equation 2 is unsaturated. If it's unsaturated, it does not have single bonds. So here's equation 2. Here's my reactant, CH2, CH2. So C with 2 H's and a C with 2 H's. I know carbon needs 4 bonds, so that's a double bond. So it is unsaturated because it has a double bond between the carbon atoms. All right, explain in terms of intermolecular forces. So I always want to write about strong or weak. why ethanol has a higher boiling point. So ethanol has stronger IMFs, of course I'd write that out if it was the test, than ethene. So I've got to compare the two, and whichever one has a higher boiling point has stronger IMFs. And the last one, draw the structural formula for the organic reactant in equation 3. Not reactant, product. So here's the product that's organic because it's got the carbons. So a C with 3 H's and a C with an H and an O. Well, O needs 2 bonds and carbon needs 4, so that's a double bond. So there we go. That is the end of the August 2016 exam. Thanks for joining me.